everyone, and welcome to Angular War Stories. What we're going to talk to you about today is our war stories from building and deploying Angular 2 applications into production. Now, a lot of war stories talks are about what people have done and what they don't like about a particular technology or framework, but you're not going to get that here today because we actually have loved our Angular 2 journey and we love Angular 2. So our goal from today's session is to help you think about the things that you need to know that you may not know already, and to help you to ask the right questions and make some really good decisions. There we go. Hi, I'm Adam Stevenson. I'm a solution architect at SSW, and my primary focus is on building large-scale enterprise web applications. So I've been building Angular 2 since it was in full production, since it was in alpha, and working on .NET Core since it was in early beta. So I've had a really fun last 18 months, and now everything's gone RTM, and life feels a little quiet.
Hi everyone, my name's Duncan. I work with Adam in Brisbane. I'm a software architect, and I also work for Fire Bootcamp, which is kind of training for Angular. And I've been really lucky over the last few years to pretty much only do Angular, involved in about 12 applications in production, all Angular 1 and 2, all in TypeScript. And we spend half of our time traveling around the world teaching people Angular. We were silly enough to actually run our first training course in Angular 2 when it was in early alpha, because we thought it would be finished in 3 months. And so we also get to stare into a lot of people's code bases and have lots of good discussions around, where the community's going with Angular 2. So hopefully we can share that with you today.
Awesome. So what are we going to talk about today? We're going to talk about what is Angular 2 and why you should care. We're going to talk about what to do if you've got an Angular 1 application. We're going to talk about module loaders and build systems. And we're going to talk about how great TypeScript is and the choice around IDEs. We're going to look at CSS frameworks and widgets, which is surprisingly more complicated than you would expect it to be. And then where the rubber really hits the road is with RxJS observables and Redux. And we're going to talk about some of the hardest things to learn in Angular 2. So Angular 2, what is it and why should you care?
So before we jump into talking about this, let's take a walk down memory lane of putting web applications in the browser. So it all started in '95 when Brendan Eich wrote JavaScript in 2 weeks, which is fairly hilarious because now it's kind of taking over the world. And then in 2002, we got XHR requests from the Outlook team at Microsoft, which was a really big deal because it was the first time we could get data without having to refresh the page. Then we got jQuery in 2006, and this was the first time we saw some of the bigger guys like Google and Microsoft and Apple all agree to use the same library rather than rolling their own. And then in 2009, we got the Chrome browser and the V8 engine, and things got a lot faster. And then we got Node.js, and we started to see, heaven forbid, JavaScript on the back end in the server. But most importantly for everybody else, we got the Node Package Manager, which is by far and away the most dominant package manager for doing front-end work. 2010, we got Knockout, but it's been knocked out. And then we got Angular in 2010, Angular 1. So it's been here for 7 years, and they've learnt a lot being the kind of dominant framework over that time. But there's been other people. In 2013, we saw React hit the scene, and it was very popular, and is still very popular today. We got TypeScript in 2013 as well, but that was only really for us Microsoft guys, and it wasn't until Angular announced that they were going to use TypeScript to build Angular 2 that all the cool kids thought that it only came out yesterday and started using it as well. So we got the latest version of JavaScript as well came out last year in 2016, and this was the first update to the language in 6 years. So it was a huge update, and we saw a lot of people start adopting it. And also Angular 2 was finally released in its full version. But what you can't see on this slide is we've had such a churn in this space. There's so many libraries and frameworks that are coming out, like Broccoli, Brunch, Gulp, Grunt, Webpack, JSPM, System.js, and they're just maybe some of the bundlers and package managers and build tools for JavaScript. But there's no one person that can stay on top of the whole kind of front-end space anymore. It's a really big topic with a lot of churn.
Now, before I hit the next point, I'm just going to call out, we keep saying Angular 2, and we'll keep saying Angular 2 a fair bit in this presentation, but there's actually new guidance come out, and the Angular team have said it's not called Angular 2 anymore, it's just called Angular. And the reason they're saying that is because it's going to be evergreen. So we're going to see a lot more version numbers coming out. We're going to see the new versions rolling through quite quickly, which is great. So it's not a big rewrite like we went from AngularJS to Angular 2. It's like Chrome. You know, we don't talk about what version of Chrome we're using. It just gets updated and it keeps rolling along. So we'll expect to see, you know, new versions of Angular coming out without making big breaking changes. And so that's really exciting that we're going to see them continually rolling ahead as we go along. Now, Angular is a JavaScript framework, right? Well, it was. When it was released, it was described as a superheroic JavaScript framework. The goal was to be the best of the best JavaScript frameworks. But with Angular 2, the message has really changed. With Angular 2, Google describes it as one framework, mobile and desktop. The goal is to be the best way to build applications for your browser on your desktop and on your mobile devices. But it's also to be the best way to build iOS and Android applications and to be able to build desktop applications for OS X, Linux, and Windows. So it's a much more ambitious goal. Now, what was the main problem with Angular 1? It was slow. If you were trying to build something that was really large and complex, you ran into a lot of performance issues. If you're trying to run Angular 1 on an underpowered mobile device, it was really slow. And the teams put a massive amount of work into the performance of Angular 2. So we've got optimized code generation. So your HTML templates are converted into highly optimized JavaScript. We've got universal for server-side rendering and SEO. So the initial page load is super fast. And we've got code splitting. So unlike in Angular 1, when you first hit the application and it downloads all of the JavaScript, what happens with Angular 2 is we have lazy loading of our code. So when you first hit the home page of your Angular 2 application, it downloads just the JavaScript you need for that section. If you navigate to the product section, it downloads that bit of JavaScript. So we're getting much more performance out of our Angular 2 applications. Now, we're consultants. We actually write code every day for a living, and I run several teams that all use Angular 2 all day, every day. And it's our favourite thing about Angular 2 is that we're actually shipping features faster than we've ever shipped them before. So productivity is a massive deal for me. Like, my guys can't agree on anything. If you bring up what's the best ORM, what's the best desktop, what's the best operating system, there goes lunchtime. But they actually all agree on Angular 2 because it just makes their lives easier. The great thing about Angular 2 is it's got the component model makes actually composing our applications really easy. The template syntax is simple but really powerful. We've got TypeScript, so we've got strong typing for our JavaScript. And we've got the Angular CLI, which gives us code generation, and it's also an awesome tool for actually producing our build output. The other thing about Angular that's different is it's a complete framework. So unlike some other libraries where you go and you take a UI engine and then you go and you choose a router and you're choosing a whole lot of different bits and knitting them together, Angular 2 out of the box comes with routing, testing, internationalization, animation, accessibility, and a production build tool. All these come out of the box with Angular. And why that's a big deal is that they all get updated with Angular as they go along. You don't get in the scenario where you've chosen all these different bits to build your solution, and a few years down the track, one of the core pieces is no longer the cool piece. Everyone's moved on to something else. And now an essential part of the application isn't getting maintained and updated, because all of these things come out of the box and they're all updated as Angular progresses. Angular is also the most popular framework. What we're looking at here is a Google Trends graph of the most popular front-end frameworks. And we can see it's really a two-horse race between React and Angular, with Angular being much more popular. But we're not in high school anymore, so why is popularity a big deal? Well, the most popular frameworks are easier to learn. There's more blogs on them, there's more online courses. When things go wrong, it's easier to find the answers to your problems because there's more answers on Stack Overflow. There's more libraries written for them. So it's really, using the popular frameworks is really important. They also last longer. When we talk about Angular 1, it's been used in production for 7 years. That's like, 140 years in JavaScript framework years?
So before we go go too much further, let's have a brief look at Angular architecture. And at the core of Angular architecture is the component. So the component is a TypeScript class, and this is where you put your business logic, your properties and methods that will drive your HTML templates. And on top of these components sits your metadata. And the metadata is what lets Angular know that this TypeScript class is an Angular component. Now, this metadata also is the glue that says this component is glued to this HTML template. And you could call this a module, which will become more important as we go on today. But you could export this component from one file and import it into another one. And if you have properties on your component class and you want to share them with your HTML template, you'd do that with property binding. And if you have events that are raised on your HTML templates, like a button click, you can listen to those with event binding in your component class. Now, if you've got other components or directives you want to stick on this HTML template, you can do that as well, and you get nice composability. And if you've got reusable logic that you want to share around your application, you can put those in Angular services, and then you can use Angular's dependency injection system to put that into these components. Now, once you've got one component or 3 or 5 or hundreds of components, they tend to form a component tree. So at the top of your component tree, you'll normally have something like this, an app component that's really just responsible for initializing your application. Then underneath that, for example, you would have, say, a to-do component, and this might be what we'd call a container component, and it's just responsible for displaying the title here. You can see an example there in the little browser window of just showing the title, but also getting the to-dos. But it's also the parent for a couple of child components. So in this case, we might have some presentational components like this to-do list component, and it's just responsible for showing a list of to-dos. And then we might have a to-do input component in blue here, and that's just responsible for putting in more to-dos. So we end up with this composable architecture in a component tree. But if we took this and we start thinking about Angular modules, which came out just as Angular 2 was finally released, which allows us to specify a section of code and all of its dependencies, we can start to do some cool things. So we could say the whole thing is just one big module and just say they're all sharing all their dependencies. But we can start to split this up. So we could say that the app component is its own module and it has its own set of dependencies. And this to-do feature, or this area in red, is a to-do module, and it has its own dependencies that it needs. But we can't really do too much just yet with this, but if we were to separate it one more step and we said, okay, we're going to have a home component, and this home component is also a module, now we can start doing what Adam mentioned, which is code splitting. So we could hit the home page as a route, and we'd get all the JavaScript in the home module. But we wouldn't get all the JavaScript in the to-do module in the red there until we navigate to that page. So the performance improvement can be quite big here, and it solves one of the problems in Angular 1. So Angular 2 itself is really easy. I never hear people complain about learning to do data binding or routing or services or components. That bit's actually much easier than Angular 1. But it forces you to confront modern web development. It doesn't matter what framework you're learning at the moment, you're going to need to do this. And you're going to have to look it in the eyes because you're going to need to learn to do TypeScript. You're going to need to learn a little bit of reactive programming and understand RxJS. And you're going to need to understand both Angular modules and JavaScript modules, and also have a pretty good to great understanding of module loaders and module bundlers. And we're going to talk a whole bunch about those today. So in summary, what is Angular and why should you care? Angular is a super fast JavaScript framework, arguably one of the fastest at the moment. And it's cross-platform. You can use it on mobile or desktop. You'll be more productive with it. It's a complete framework. You don't have to go shopping around for all the bits. And it's enterprise friendly. Surprisingly, we have enterprise and government clients come to us and they're already chosen Angular 2. So we don't have to do any hard sell. They've already come having chosen the technology. But let's not forget that when you get a new framework, then you're going to be able to be more ambitious with what you want to build. You get a lot more functionality, even just one example with the code splitting there, that you'll be more ambitious with what you're going to build in your projects.
So let's talk about Angular 1 versus Angular 2. Now, the choice of framework is a big deal. If you're here because you're deciding, what framework am I going to use for the next project at work, this is something your company's going to live with for years in the future. And it's also a really personal decision because it's the technology that you're going to become a specialist in. It actually is going to affect your next job and what happens with your career down the track. So it's really easy to choose a new framework when you're starting a new project. But what if you've got a new feature to build and you've already got an Angular 1 application? Here's something I want you to think about. Every line of Angular 1 you write today is technical debt. If you spend the next 6 months writing Angular 1, somewhere down the track, that's 6 months of code that you need to go back and rewrite to a more modern framework. So it's actually a really big deal. So what if you've already got an Angular 1 project? Well, most people think there's two options. You can either do a rewrite or you can do an upgrade. Let's have a bit of a look at what those options look like. Now, it is actually possible to put Angular 1 and 2 in the same project using something called the upgrade adapter. But we don't recommend it. So the benefit is you get to start writing Angular 2 today, but it's a lot of work. It's a big refactor. There's performance implications because now you're constantly jumping between Angular 1 and Angular 2 in the same project. And there's a big learning curve and you're introducing a lot of complexity. What we say to people is maybe it's better to start writing Angular 1 like it's Angular 2. So you can start using Angular 1 you can start using TypeScript in your Angular 1 applications today. You can also introduce a module bundler, and you can start using Angular 1.5 components. And what this is low risk. It lets you start learning the Angular 2 concepts, and it gives you a faster future path to a rewrite. It's still going to take you 3 times as long to get to Angular 2. It's a much slower process, but it's a lot safer. The downside, of course, is that at the end of the day, you're still actually writing Angular 1. Now, I'm sure there's a few of you going, that all sounded so good, I'm going to go and convince the boss on Monday that we should do a big bang rewrite and we should rewrite our application in Angular 2. And that's a bad idea, okay? So while it sounds like fun, you get to go file new project, you get to start writing nice, clean, new code in Angular 2, there's obviously big downsides. It's high risk. So you're maintaining an existing application while you're building a new one. You're getting bugs coming in for your existing application and you update them in the new one, but then they don't get updated they get updated in the existing app but not in the new one. And you're introducing bugs as you're moving features from your old app into your new one. And the major issue is that you're recreating the problem. And your boss knows that in 4 or 5 years, you're going back to him asking for approval for another big bang rewrite. So the approach that we try and take on most projects is to rewrite your application into several smaller apps. So what we do is we abstract out some of the common things. So we abstract out authentication, we abstract out styling, and then when you get a nice big new chunky feature, you build a separate Angular 2 application just for that feature. So an example of that is that we had a big enterprise client and they had Angular 1 sitting on an ASP.NET MVC view. So they came to us with a new feature, so we added another MVC view, put Angular 2 on top of that, and then the new feature started writing just in Angular 2. So that works really well. So the benefit of this is we get to start writing Angular 2 today. It's easy to get approval on new tech because all you're doing is you're just getting approval for new tech for just a new feature. And you don't have to do any more big bang rewrites. The downside is you've introduced some DevOps overhead.
And this has actually been a really interesting experience for me. Last year I got the chance to write 3 smaller Angular apps in Angular 1 for a customer. And they're all styled to look the same, so they all came together to be one big app. And they bought some DevOps overhead. They had to build their own auth service, and that was a bit of a pain. But now they're in this prime position where they're going to build a 4th small app for this kind of bigger application, and they've got a choice of what they want to use for technology. So they're going to do that in Angular 2, and they can cut their teeth with that in a greenfield project. So they're in quite a unique position there, which is quite good. And I think if you're sitting in the room today thinking, how am I going to get, our Angular 1 app to Angular 2? Or, am I going to put it in there? Or are we going to do a big bang rewrite? I think you should also be thinking, maybe is there ways that we can actually just leave our functional Angular 1 code and just write a new smaller app in Angular 2 and not necessarily have to redo all that work?
So in summary, writing Angular 1 is creating technical debt. It's a lot more effort to migrate slowly, but it's a lot safer. But what we really think you should be doing is considering how you can rewrite into smaller applications.
So let's have a talk about module loaders and build systems, because this has been a big part of our journey moving into Angular 2, and it's just a big part of all front-end frameworks at the moment. So the big problem we had is Angular was slow to initially load, and that's because you've got to stick the entire application in the browser on the first load. You can't load it down in parts. And for that reason, we also had these big complicated build system. We'd have like 900 line gulp files that would hand roll to try and crush down the size of our applications that would send down to the browser. But we still inevitably, on some of our bigger applications, we had slow loads. So it wouldn't be uncommon to have like 5 to 10 seconds for the initial load on a big complex dashboard. And it's kind of a funny time because JavaScript used to be really simple before. All I needed to do was have a script tag and a HTML file, and I was right to go. But in Angular 1, the simplest way that I could get started today is like this. I could stick an angular.js file in a folder, get an HTML page, and I'm ready to go. But the simplest way I can start today with Angular 2 is to use the Angular CLI, which will, a single line in the terminal will build me an application that looks like this. But this is 48,000 files and 350 megabytes.
True.
And you can't stick 48,000 files in the browser, yeah? So you've got to figure out which of these 48,000 files you actually need, and then you've got to put that into a separate bundle. And this is where module bundlers come into it. It will do that for you. So the way that this works is you need to be able to use both JavaScript modules and Angular modules to specify up front everything a file needs so you can statically analyze your application. So with ES6 modules, it works with import and export statements. So imagine I have this math.ts file here, and I'm exporting this sum function. It just adds x and y. And then I can import that with the import keyword into this calculator.ts file, and then I have access to that sum function. So if you declare everything you're importing and exporting into every file, then you know everything that file needs, and then you can start analyzing it. But right at the end of the journey to Angular 2, they realized if they go down this path and they absolutely specify everything, every ng if, every time you need an if block or a for each in your code, you'd have heaps of imports, maybe 20 imports in every page. And they said, let's make this easier, and we want to do some other features. Let's bring up our own module system. So they also brought Angular modules onto the scene, which at the time I thought was crazy, but it's actually a really nice way of actually being able to get new features and also reducing the amount of kind of duplicated imports and exports everywhere. So once you've got these Angular modules and these JavaScript modules and you're specifying everything and you kind of know everything your application needs, you can go, well, I've got this JavaScript file and it needs these TypeScript files and this Sass file and this file needs this next file and so forth. And you come up with a dependency graph. And you pass that to a module bundler like Webpack or the System.js builder, and it can bundle your application for you. So you could just go and bundle it into one big bundle, or you could get a bit more advanced and you say, well, let's separate all of our third-party libraries into another bundle and have a vendor bundle, because we can do some better caching with that because it's not changing very much. But then you can get even more advanced and you can separate it out into multiple other bundles because you can lazy load bundles. So if you have an Angular module and you're using the CLI, what you can do is you can say, well, can you just package that up into another bundle before we actually deploy our application, so then we can do this code splitting we've been talking about. So the module bundler becomes like a really important part. Otherwise, how do you know which of those 48,000 files you need? Another problem we had is templates are currently compiled into executable JavaScript in the browser, both in Angular 1 and 2. So what do you think the problem with that would be? Well, it's going to be slow, yeah? It's going to be a performance problem. Not only do you have a performance hit when you have to download a little 200 kilobyte compiler into the browser, you also have to do that compilation in the browser. So this is happening at the moment unless you're turning a certain flag on for both Angular 1 and 2. So this is where AOT can really help. So this is ahead of time compilation of your HTML templates. So in Angular 1, you have to run it in the browser. You can't run it offline. So you would make a request to get your HTML template, and then you would parse that in the browser, and then you would make some DOM, and then you would have executable JavaScript that you could run. And you had to do it in the browser. There was no other way. Whereas with Angular 2 and higher, you can make that same request to get this HTML template, but you can parse that on your machine with Node, and then you can make executable JavaScript, and you can pass that straight to the browser. So then you're getting better performance, and it's highly optimized inline modules. So that's the better way to go. But there's more to the performance. There's AOT compilation, there's inlining modules, there's tree shaking, there's minification, there's a whole bunch of things. And this tree shaking is a really interesting idea, that you can kind of shake your code base and shake out the code you're not using. So if you're not using the Angular router, or you're not using Angular reactive forms from their framework, then you can kind of shake that code out, and you won't have to ship that down to the browser when you're running your app.
So what Duncan's saying is that to build our applications, we need to copy fonts, compress images, lint TypeScript, compile our lesson Sass into CSS, compile our TypeScript into JavaScript, do minification, do bundling, run our unit tests and end-to-end tests, yeah? And now you're telling me I've got to run an AOT compiler, do tree shaking, and then go and build separate bundles. Seems like a lot of work.
It's your job.
Yes. It's getting very complicated and time-consuming to roll your own build process. So we've got a bunch of war stories about this, but I used to think I was like a build tool warrior. So when I started off Angular 2, we were writing 800-line gulp files. So all of those tasks, we'd go into gulp and we'd go and get NPM packages, and literally 800 lines is what it took to get our Angular 2 app ready for production so that we could ship it. So, and that worked fine at the beginning, and we'd do all of those tasks, and then we'd copy that across to our dev server, but we're still copying across 48,000 files because we're copying across all the node modules. But we didn't think that felt right going to our prod server, so then what we did was that when we had a mapping and we created a special file that said, out of those 48,000 files in our node modules folder, here are the ones that have got to go to our production server. Yep. And we're like, hey, this isn't really quite right. There's got to be a better way. And that led us to our first big epiphany, and that's that you need to understand module loading. Okay, so we did some investigation into this, and we found out, we shouldn't be doing this. What we actually need to do is go and get a module bundler, because what's happening is our angular.min.js, we can't just copy that across anymore because it depends on 10 files, and those 10 files might depend on another 10 files. And I'm sure there's people in the audience going, you're an idiot, you should just go and get Webpack. And we'll come to that. But what we realised was that our process really needed a module bundler. Because what a module bundler does is it'll go and traverse that dependency graph and find out exactly what are you using, just get the bits that you're using and bundle them up together. So we went and got the system.js builder and included that in our gulp file to actually do our bundling. So we had our gulp file and it was working, but it was still 800 lines, and that's a lot of work. And we had people telling us, hey, go and check out Webpack, go and check out the Angular CLI, and there were different options. So Webpack's an advanced module bundler, so it'll package your application for the web. Who'd have thought about it? It's very advanced and it's very customizable. And then there's the Angular CLI from the Angular team, and it's a command line utility that'll do code generation, and it'll also build our application for us very, very easily. So I've already talked about Gulp. It's a lot more work to use Gulp, and it's not really the best tool for packaging your application for the web. Webpack's awesome. It's super powerful. It gives you advanced module bundling. It's the most popular module bundler out there. It does tree shaking. It's got really extensive plugin support. The downside is it's complex. So we find that most teams that end up going down the Webpack route end up having a guy, and he ends up being a Webpack specialist. And he's the guy who writes the build, he maintains the build, he fixes it when it's broken. Are there any Webpack guys in the audience? Oh, there's none. Oh, that's so we can talk about them. So, like, Webpack guys are like, it's not a cool job. It's kind of like the new equivalent of the Crystal Reports guy. So, the downside of Webpack, super powerful, but you've got to get a Webpack guy. The Angular CLI is what we think most teams should go to. It's a simple command line tool, but it uses Webpack under the covers. It lets you scaffold out and create an application. It lets you generate code. It's a production build tool. It's developed in lockstep and follows the style guide. So the Angular style guide is the guidance from the team of here's how you should, all the best practices, naming conventions, how you structure your application. And the Angular CLI are developed in cooperation. So the easiest way to see a good example of best practices of Angular 2 is actually to use the Angular CLI to create a new app and then look at how they're doing it. It scaffolds out your unit testing and end-to-end testing as well when you create an application. The downside of it is it doesn't have Webpack plugin support yet. So if you need a customized build, you've got to fall back to using a really customized build, you need to fall back to using Webpack. Let's come and have a look at how using the Angular CLI looks. So the ng command is the command we use for the Angular CLI. So if I want to create a new project, I just go ng new, this new command creates a new project, and give the project a name like CLI demo. I hit enter, and that's going to run through, and it's going to create all the files I need for my Angular 2 application. If anyone's gone through the angular.io getting started guide or any of those things, that can take quite a while just to go and create all the config files, where this just spits it all for you out, straight out of the box, including wiring up end-to-end and unit tests. So I can go and have a look at that, and here's how that looks in Visual Studio Code. So I've got my application all scaffolded out, ready to go. I can jump straight back to my prompt, and I can go ng-serve, and it'll run my application. So it bundles it up, packages it up, and it'll run in my browser. It's that easy. Now, let's say I want to add a new component. So I'm going to use the generate command. I'm going to go ng space generate. I'm going to say to generate a component, because you can generate other things as well. So I'm going to go ng space generate component and give the component a name. I'm going to create the home component. That goes through, and you can see that's going to generate the CSS file. It's going to create the HTML template. It's going to create the spec, which is the unit test file. It's going to create the TypeScript class itself, and it's going to add this component into a module. Now, we've all seen demos of code generation. I remember seeing the MVC demo and thinking, wow, that's awesome. But then you go to use it in production and it never quite cuts it. This is completely different. So all of our Angular guys, they use this all day, every day. It's actually the easiest way to generate components. So we can go in and we can see here's how it looks. It's all there, ready to go in our editor. So let's go and build it. So instead of writing 800 lines of gulp, you can just do this. ng space build and pass it two parameters, prod and AOT. And what this is going to do is this is going to go and do that big long list of tasks that I said before, including doing the tree shaking out any unused modules that I'm not using. And it's going to do the ahead of time compilation that takes all of our HTML templates and converts them into highly optimized JavaScript. So there it is, it's made my bundles. Let's go and have a look. So what that ends up doing is it builds it for production, including AOT, and puts it in the dist folder. So I've gone from 48,000 files down to 8. Okay, this is what I copy and paste to my web server. You can see there's a fave icon, there's an index.html, and then I've got my bundled JavaScript, highly optimized bundles. Okay, so if I've gone, you can see here there's one for the vendors, there's my main one. So this is the highly optimized JavaScript, and this is all I need to ship to my web server. Pretty cool? So I go and I copy that to my web server and I run it up, and here's my app running. I'm a real developer, that's how it looks. You can see here, what's nice is you can see it's in total 457K. Now when you consider that jQuery by itself was 256K, that's pretty good. So we get asked this a lot, is the Angular CLI ready? And this was a real issue for us in the early days because the Angular CLI was very, very new. Webpack had a heap of support. There was people using, I know you had, JSPM was like the next generation package manager, the package.
But it's dead now.
It's dead. So there was a lot of, everyone had their favorite. There was no clear answer about who was going to be the winner. But we're at the point now where we have a very clear answer. So if you're starting with Angular 2 today, you should use the Angular CLI. 95% of the projects we're doing, the CLI is perfect for. If you've got the requirement for a highly customized build, you should use Webpack. But just don't jump into it straight away because
But you need a Webpack guy, because we pick up and help other people with projects, and they're 3 months in, and no one's the Webpack guy, and their Webpack's 3 months out of date, and Angular changes quite quickly at the moment, and they're not able to use any of the new features, and they have to redo their build system because they just copied and pasted someone else's Webpack 3 months ago or 6 months ago. So it's a pros and cons, but unless you really need to have a customizable Webpack at the moment, the CLI is going to save you a lot of problems. And you can just eject it from the CLI, which is a feature that's coming, and go your own path later on if you want to. So last 3 production projects we've done in Angular 2, or 2 are shipped, one's about to ship, all using the CLI. So we've been using it.
Can't recommend it highly enough. Oops. So in summary, use the Angular CLI, use a custom Webpack build only if you need it.
Cool. So let's talk about TypeScript and IDEs for a minute. Now, TypeScript's a bit of a no-brainer, but the IDEs has really been a source of pain for people. So okay. So one of the challenges is, again, with Angular 1, and most people wrote their Angular 1 in JavaScript, is when your application scales, it gets hard to maintain large code bases. And if you're like the old Azure portal that has like, I think, 1 million lines of JavaScript in it, that can be pretty hard to maintain. Let's change clicker. So large JavaScript code bases can be hard to maintain, and that's because they don't have strong typing. So they don't have some of these features of TypeScript. And they're difficult to refactor. If you've got to rename a variable across 100 different files in your application and they're just based off string, you don't want to be the guy to pick up that task off the backlog. You want to give that to somebody else. So you've got a couple of choices when you're building Angular 2. TypeScript is the default, and that's what most people are doing. But you could choose to use ES6 or just vanilla JavaScript, or you could use Dart. But I haven't met a single person still to this day who doesn't work at Google that uses Dart. So we're just going to talk about TypeScript and ES6. So TypeScript gives you strong typing. If you haven't seen TypeScript before, I'm not going to go into detail about it. You should definitely go check it out. But it gives you strong types. It gives you amazing tooling and refactoring. And for me, in my job, this is by far and away my favorite part, to be able to refactor my code and navigate my code and have confidence to do that. But Angular itself is actually written in TypeScript. So Angular 2 is written in TypeScript. Everything is in TypeScript. All the docs, all the third-party libraries, everything, all the lessons, all the tutorials, all in TypeScript. So it's going to be much harder if you don't use it. But you could use JavaScript if you want to, but it's going to be trickier for those reasons. Now, IDEs is surprisingly a real pain point. So there's 4 big ones I'm going to run through. So the first one's Atom, that's very popular. It's got a good support for TypeScript through a plugin, and it's fast and lightweight. The next one's Visual Studio, which is by far and away, in my mind, the best IDE for doing C#. But it's not necessarily the easiest one to configure to use Angular 2. I didn't find it too bad, but we have a government client and they've got 4 front-end teams, and they got mandated at the very beginning that they needed to use Visual Studio. And they were also learning Angular 2 at the time. And man, did they scream like little boys, because they were just having such a hard time getting the new language features in TypeScript working in their IDE, and also getting it to work because it's just a set of folders versus a solution and so forth. So surprisingly, we've seen across all of our travels and teaching, which has been like over a year now with Angular 2, that on their own, every team who does C# on the back end use Visual Studio on the back end with C#, and they all use Visual Studio Code on the front end. So that's just been a really common thing, like at least 90% of the people we see. So Visual Studio Code is a great lightweight editor that you can get. It's got amazing TypeScript support. It's fast and it's lightweight. And there's a whole bunch of really unique Angular 2 features that you can utilize by getting the extensions. So one of my favorite things is you can get IntelliSense in your HTML for your properties and methods on your actual Angular components that are relating to that HTML template, and you can navigate back and forth. And on top of that, you can get auto importing. So like using statements in C#, you can just say, I need to import this variable, rather than having to type out the import at the top of your TypeScript file. Now, the other one that's really popular is WebStorm. And WebStorm has all of these unique features out of the box. It's a bit of a bigger IDE, but it's very popular. So if you're going to be writing Angular 2 all day long, you probably want to be looking at one of the bottom 2 here, Visual Studio Code or WebStorm. You can get it working in Visual Studio, and it's definitely not a deal breaker, but it's nowhere near as popular in the community at the moment for Angular. So in summary for TypeScript and IDEs, we think you should use TypeScript because it's the default, and you should keep your current IDE for your back end, but you should use Visual Studio Code if you're going to be doing your Angular for your front end. Now, another big pain point, so the IDE thing was surprisingly a pain point for a lot of people, and another big one was CSS frameworks and widgets, and it's still actually probably one of the most painful ones when you're deciding which ones to use. So if you want to have an awesome UX, you're going to need to have a good UI library. You don't want to go roll your own date pickers and accordions and all of those sort of things. So you need to make a choice. And when you're 6 months down the road in a team of 10 developers with a UI library like Bootstrap, you don't want to go tearing that out and swapping it out for something else. So it's a pretty important decision. So we really believe it comes down to these two. You've got Material 2, which is a ground-up rewrite of the very popular Angular material for Angular 1, which implements Google's material design specifications. So it's a material design for a set of components written purely for Angular 2 or higher. And then you've got Bootstrap, which since 2011 has been super popular and been a great tool for being able to do responsive layouts and CSS and styling of your page with some basic components. And there's a whole bunch more. There's PrimeNG that's worth checking out, Polymer, NG Bootstrap, Widgimo, Kendo UI, DevExpress, Semantic UI, Materialize, Vaden, and a bunch of others here. Now, the reason I'm showing you this is everybody in these component vendors are heavily investing in this space because they got such a good return from Angular 1, but none of them are quite perfect just yet, or they're only just kind of starting to get close to that. So what we're all used to, where we just get one vendor and we get everything from them, is not quite there yet. You're kind of needing to pick and choose from a couple still. So it's still a bit of a pain. So we really believe it's between these two. So we think Material 2 is going to be the default in time. You know, at the moment for Angular 1, Material 1 for Angular is the default. There's full-time Angular team members working on this. I think they're close to 5 full-time members working on it. So they're very high quality. It keeps pace with Angular, so when the AOT or ahead of time compilation came out, Angular Material was already implementing it. And you got first-class Angular integration. It's pretty much glued together. It's designed to be together. But it doesn't work with Bootstrap, so it really is one or the other at the moment. So we had a student implementing a Material kind of coursework that we have for them, and then they wanted to extend it, and they wanted to add a Bootstrap dropdown, so they bring in Bootstrap, and the whole application kind of stopped working, and they thought it had broken it, but it was really just the CSS clashes so much that it looks broken. So it really is kind of one or the other at the moment in this direction. So the other thing, it's in beta. It's moving very fast, but there's the big challenge is that some components are missing. So there's no date picker, there's no accordion. I rewrote our course documentation in Material 2 the other week, and there was no accordion, so I had to go make an accordion. It's only a couple of hours, but now I have to maintain it and keep it up to date if people want it to do different things. And I kind of don't really want to write those pieces myself. I just want to write the application. So Bootstrap's still a great choice. It's not really, we think, that you can't use Bootstrap. So most component libraries support Bootstrap. There's lots of non-Angular libraries as well. So we had our first big Angular 2 project up here in Brisbane. Our customer was very used to Kendo grids. So they wanted to have Kendo grids in their Angular 2 app, but there were no Angular 2 Kendo grids yet. So we just used their jQuery implementation that's styled in Bootstrap, and we were using Bootstrap, and it was just really easy to make it look the same and plumb it in. So for styling-wise, there's a lot more choices with Bootstrap. But it doesn't work with Material, like I said, and you're going to have a dependency on maybe on jQuery most likely, and the Bootstrap CSS. Now, a lot of people in the Angular community think jQuery is the devil, and that you don't know how to program if you use it. And I don't know if it's that extreme. And I think a lot of that came over from early days of Angular 1, where lots of people were using jQuery to manipulate the DOM, which is not what you should be doing when using Angular, because you've got a framework for that. But people still today are very scared of it, and we've had some clients rewrite all their own components because they didn't want to have jQuery in their app. So you also got to watch out, because this ahead-of-time compilation might not work with all of the component vendors early on. And it's really a deal breaker. If one of the third-party libraries you have doesn't support it, you can't run it. So this in time won't be a problem at all, but you might need to be careful if you pull some small library off GitHub to do a toaster, for example, and it doesn't support AOT yet, then you can't run AOT for your whole app. So in summary, for CSS frameworks and widgets, we think you should use Material 2, and that you should patch the components that they don't have just yet with other people's components, either on GitHub or libraries that are Material styled. Now, this is a really crazy thing to put up and say that everyone in the room should do this, and some of you are probably looking at me going, we're not doing that. And that's totally fine. We still do a lot of projects in Bootstrap, and it's a great way to go as well. But we're definitely looking at doing this because it's getting very close for Material 2 to be able to actually do it. Okay.
So let's talk about observables, RxJS, and Redux. This is the part that hurts people. This is the part where most people and most teams coming to Angular 2 really struggle. And why is that? Well, modern web applications are composed of asynchronous events. You've got your view, you've got a button on it, you click a button, the button calls a service and the service performs a HTTP request. You've got the user, he sits there and he bashes the button a heap of times, shoots off a bunch of HTTP requests. You don't know how long each one of those is going to take to return. You don't even know what order they're necessarily going to return in. Async code seems hard to write, hard to refactor, and hard to debug. And our web applications are inherently asynchronous. But we've got RxJS to help us out. And RxJS is the JavaScript implementation of reactive extensions. Now, the whole point of RxJS is to simplify the async code that we're going to write. And it's baked right into Angular 2. So if you're going to perform a HTTP request, you're going to use RxJS. If you're going to work with reactive forms, you're going to use RxJS. Even accessing things like the router, you're going to use an RxJS observable. And this is probably the number one area where we see people, where we think people should spend more time up front investing in learning. You know, as Duncan said, the syntax is easy to learn. We don't get people complain about it. Composing applications is great. RxJS takes a bit to get your head around, and we think this is the area where people need to spend some time, do some courses, and really invest in understanding. So what we're going to try and do here is just introduce some concepts that are going to help you in your learning as you go along. So RxJS is the JavaScript implementation of reactive extensions, and reactive programming is about applying the observer pattern to streams. So there's really two things that you've got to get your head around: the observer pattern and streams. So the observer pattern, let's talk about the observer pattern first. Let's say we've got an array, and that array is important to our user interface. And when the values in that array change, we want to update the user interface. Now, we could do polling, but that doesn't feel very efficient. What would be better is if we could have an observer, and that observer was watching our observable, and whenever the observable changed, it emitted a new value. Okay? So we've got an operation, and then when that operation is applying on the observable, and when that observable changes, we're emitting new values. So what a lot of people miss is that you can also have multiple observers all applying to the same observable, but with different operators. And we can even chain operators together. So that's all the observable pattern is. Now, the other important facet is streams. And so streams are really data coming into us over time. So imagine we don't have the whole array up front. Imagine that you've got a user who's got a calculator UI, and he's pressing numbers on a keypad. So he presses the number 1. And we've got an observable that's applying an operator, and that's emitting the value of 1. Then we've got values streaming in, and as the values are streaming in, our different observers are emitting new values. Okay? Now, the output of each operation, of each operator, is another stream, and we can actually chain streams together. So what does that look like when we're actually applying that in real life using RxJS? Well, the canonical example is a type ahead. So when we've got a text box, we've actually got the value changes observable. And that's going to emit a new value whenever new values are put into the text box. So what we can say is we can watch the value changes observable, and then we can apply a debounce operator. And the debounce operator is going to say, only emit a new value after 500 milliseconds of inactivity. We can change that together with a distinct until changed, which says only emit a new value if this value is different to the previous one. And then we can do a switch map. Okay, and what a switch map is going to do is it's going to switch between streams. So then I can go out and call my album service and do the search. And the nice thing about switch map is it's going to cancel the previous request. So that's how we can chain operators together to create a type ahead. Now,
yeah, so if you're anything like me when you first see that other slide, when you're learning RxJS, you'll go, whoa, what are all these, like, there's lots of operators. Like, you could fill up a slide, there's way more than 50 operators. And learning RxJS is definitely a journey. Like, the first time you do a HTTP request with Angular, you get back an observable and you subscribe, and it's really easy to do, and you're like, oh, I got this, it's pretty good. But then you get further into it, and you get a bit more ambitious, and you start trying to be more declarative and chaining operators, and you go, oh, I need to combine two streams. You're like, oh, I got this. And then you're like, oh, no, I don't got this. And you're back to the docs. And you're trying to look through the documentation and figure it out. And you're like, oh, cool, I can use combine latest. And then you get it. And you go, okay, I'm combining two streams. And you're back at it and you get more ambitious with it. And then you're like, oh, now I need to flatten out an array of an observable. So I've got an observable of observables and I need to flatten it out. And then you're like, oh, I got this. And you realize, you don't got it. And you're back to the docs again. So you'll be more and more ambitious with it as you get further into it. And you'll be, flattening out streams and combining streams and chaining operators like you saw in the other thing. And it takes time to learn. It's definitely an ongoing journey. Even last night I got a blog that my friend wanted me to proofread, and I'm like, oh, I know this operator, and then I get this other one. I think it was like Pairwise or something. I'm like, I haven't even heard of that one. So you'll find that, it's definitely a journey, and you get deeper and deeper with it, and it's worth investing up front some time to learn.
Because I think one of the key things is the code that we're writing, it's a journey, but the code we're writing would be much, much harder to use if we weren't using RxJS.
Mm-hmm.
So in summary, modern web development is asynchronous. And RxJS takes some effort to fully understand, but it really is going to simplify writing your code. And it's important to invest in because it's baked right into Angular 2.
So in Angular 1 and still in Angular 2 by default, state management is still, for me, the hardest part of writing Angular applications. You've got to manage the state across your application, and it's the most buggiest code that we've ever written. It's the code that people argue with me the most. It's the code that needs the most tests, and it's the most expensive code we write is trying to manage state. So this is something that's still a really hard thing to do. And what would happen is our applications would turn into these large bowls of mutable soup where we would have kind of, say, a user object, and that user object, the piece of state around that user object is in, say, 10 different parts on the page. It's up in the menu for their login, and it's in a list, and then you open a modal, and you've got to update that user in the modal, and then you've got to close the modal, and then you've got to update the list, and managing that state can become really tricky. And this is where the Redux pattern, which is a way of implementing a predictable state container, can really help us. So I'm saying Redux here with a little r to reference the pattern versus with a big R, which is the actual library for Redux. So Redux kind of all revolves around this idea that you have a store. So the store is a single place where you put all of the state for your application, and it's just a JavaScript object. So if you think about having this user object, or an array of users, you would have this in the store, and you want to get a user from it, you would subscribe to the store, you would get down that user, and then you can display it in the view. So displaying it in the view is nice and easy. It's normal the way we would do it, but imagine this user object had an email property on it and you want to update it. What I would normally do is I would just pass it back to my component, mutate the object there on the spot, change out the email, do post to my server and update the server, and then pass down the object straight back to my component. But in Redux, you wouldn't do that. What you'd do is you'd dispatch an action, and that action is, these words are very specific to the Redux pattern, would have the action of update the user, and it would have a payload of the actual object that I want to update, and you would pass this in to the reducers. So the reducers are the only place that you would change state in the application, and you wouldn't mutate the state of it. What you'd do is you'd actually make a whole new user object, and you would pass in the new updated email that you want on that. So once you've updated the state, the reducers would flow through to the store, and the store would be updated, and the state of your application would be updated in this single spot, and then that would flow down into your view, and you get this kind of one-way data flow here. So if you take this Redux pattern, and you take this RxJS stuff that Adam's been talking about, and you take the Angular library, you get a new library, because we all need more libraries, and that's called NGRX. So NGRX supercharges the Redux pattern with observables in RxJS. And you get people talking about it like this. They say, NGRX is a tool and a philosophy that will revolutionize your applications and your development experience. And this is pretty outlandish, and Adam and I always joke when we go to user groups, how do you know when someone's using NGRX? And it's usually that they tell you that they're using NGRX, because it really does, people get really passionate about it, and we're huge fans of it. I'm a big fan of it. But people get really into it for a big reason, and it totally changes the way you write your applications and structure your applications. Like when you look at a component, what you inject into that component is just the store. Normally, if you're used to doing dependency injection with Angular, you might have 5, 6, even sometimes up to 10 things injected. But now you just delegate all that work out to the store. You no longer inject the router, you no longer inject services, you just kind of dispatch actions, and then you're going to be managing those actions and updating and just subscribing to the store. So it really changes the way you architect your application. So this is a demo app we get our students to build. It's just a really basic CRM application, and we get them to do this to learn NGRX. So if you load up the NGRX tools, they've got great debugging tools. They look like this. So here you can see we have a list of companies in the top with our little view of the browser here, and underneath we've got our tools. And here you can see all the actions that were dispatched when this application loaded. So first it initted the store, and then there was a navigation to the default route, which is the companies list here. And then it said load companies, because when the component loads, it dispatches that action. So this is the list of actions here on the left. And here's our state over here on the other side. And our state at the moment just has a companies array. Normally you'd have like a companies array, and then a users array, and then a products array, and a bunch of other state that's in your application. But in this case, we just have these two companies. So if I click on the delete button up on the top right of the page here, and I delete this, that would dispatch an action. And that action would go through that cycle we saw before, and it would delete the company, and then that would flow through, and now our state, after we dispatch that action, would just have one company in it, and also the view at the top of the screen would be updated. So this is kind of the flow that it follows, but you get these great debugging tools. So I could click the play button down here in the bottom of these tools, and it will replay the state since the beginning of the application. So here you can see that there's no companies in the top of the page because it's just initializing the app. And then it's load companies is fired, and then delete companies gets fired as we move through the state here. And then as delete companies is called, then there's only one company, and it's finished playing the state. But it's pretty cool. You can kind of go back and forward between the state of your application, and debugging, is very different than setting breakpoints or console logging. So once you've got this, you understand this, and you have to make a choice on whether you're going to use NGRX, there's some pros and cons. So NGRX is great for state management for a big application. It definitely makes it easier because the only place state changes is in the reducers. You get better tooling and debugging like you just saw. You get simpler builds, you get performance improvements. You can start utilizing some change detection strategies in Angular called on push. And it's much easier to test. We see this trend when people use this, that they don't test any of their Angular code except the reducers with unit tests, because the rest of their application is just kind of framework logic. All they do is they inject the store everywhere, and they just use the framework. So they only test their reducers, and they write end-to-end tests around the rest of their application versus lots of unit tests. So it kind of changes the course you go through. And it's getting a lot of traction. The last 3 big applications we've been involved with have all moved to using NGRX. So why would you not use it? Well, it's another new thing to learn, and when you're learning Angular, there's a bunch of new stuff to learn already. It's pretty overkill for a simple application. So if you've got an application that's got, say, 10 pages or views, and most of those views only have 1 or 2 components, and you're not really sharing state across your application, it's probably overkill and you don't need the overhead. It's another dependency, and it's a dependency that changes, like I've said several times, changes the way you write and structure your application. And you're going to be all in with RxJS, which for a big application can be a good thing to get some of those benefits, but you're going to need to be able to combine streams and flatten streams and know at least kind of 10 or 20 operators off the top of your head over time. So you've got to think about that when a new team member comes on board. Do they necessarily know all that? And then they're going to have to get upskilled on that. But for big applications, it's fantastic. So we think for that reason, you should learn RxJS, not NGRX, RxJS, to simplify your async code. And you should actually spend some time up front learning it. Don't just, like when people learn TypeScript, they just start hacking away and they kind of get it. It's a beautiful kind of extension of JavaScript. But RxJS, you probably need to actually sit down and do a course in. Redux is great, but we think NGRX is amazeballs, and using observables with it makes it even better. And we think you should use it with your large applications. So we're a fan of using NGRX for bigger apps. So we really value feedback. Would really appreciate it if you guys take the time today to go online and go to your Ignite portal and give us some feedback. And in summary...
So what we've had a look at is, we had a look at what is Angular 2, we had a look why we think it's excellent. We pointed out that it's actually easy to learn Angular 2 itself, but it's worth investing in learning module loading and RxJS. We had a look at the fact that writing Angular 1 is technical debt and some options for upgrading. We talked about module loaders and build systems and recommended the Angular CLI for most people, but going and getting a Webpack guy if you've got really customized requirements. We talked about how TypeScript makes writing your application much easier, and how Visual Studio Code is an awesome IDE for Angular 2. We talked about the choices around CSS frameworks and widgets, how RxJS makes writing async code much easier, and how Redux is great for building large, complex applications. Guys, thank you very much for joining us today. Come down and say hi to us down at the SSW TV stand, and enjoy the rest of the conference.
And we have about 20 books. So if you got one of these, we wrote a book on Angular. If you got one of these yesterday, then you probably don't want a second one. But we've got about 20 if people want them. If we run out of them, then hit me up on Twitter and I'll send you a PDF.
We've also got brochures for our Superpowers tour. We're doing a one-day event all around Brisbane, Sydney and Melbourne.
I'll pull them out.
If you're interested, we've got some brochures. So it's only $49 for a day of training.
And if anyone was at the testing talk and learnt about Wallaby yesterday, we've got a few Wallaby stickers and magnets left over if you want to grab some.
So I've got the brochures for the one-day Superpowers tour is over here.
Yeah, go for it.
Thanks for coming.
Yeah.